quadratic formula, which we briefly looked at last week. So last week we solved the discriminant, and we're going to use that on the worksheet to finish solving the equation out. So quadratic means x squared, right? And equation means it has an equal sign. So if the biggest power is x squared and it has an equal sign, then that means we can solve it using the quadratic formula. Alright, so if you have an equation like this, 3x squared plus 5x minus 3 equals 10x plus 7 minus 8x squared, this is like an extreme case, but you would move everything from the right to the left. So you would subtract 10x, you would subtract 7, you would add 8x squared. That's your first step. Like I said, we did that step already with discriminant, but that's going to be your first step. And then the next thing you're going to do, obviously, is group all these terms and combine them. So, for example, 3x squared goes with 8x squared, 5x goes with minus 10x, minus 3 goes with minus 7. So that's our next step. It's going to be to group like terms. So first we got 3x squared plus 8x squared. That is 11x squared. What about 5x minus 10x? Negative 5x, good. And minus 3 minus 7? Minus 10. Alright, so that's our step 3, combine like terms. And why do we do that? Because the quadratic formula has what in it? A, B, and C, right? And so we can easily figure out now what the A, B, and C are. A term is going to be 11, B term is going to be negative 5, C term is going to be negative 10. So again, last week we determined the discriminant. Okay, so step 4, make sure it's arranged from highest power to smallest power. You could just write step 4 arrange, really. Again, we've already done this for the discriminant. Step 5, fill in anything missing. So for example, if it's just x squared, the coefficient is 1. Yeah, basically fill in missing coefficients. That way you know what A, B, and C are. And once you do that, then you figure out A, B, and C. So again, your A is your coefficient of your x term. Your B is your coefficient of your, A is coefficient of the x squared term, B is the coefficient of the x, and C is the number by itself, so in this case negative 10. Actually, going back to filling in what's missing, you could also be missing a constant term, right? Like if it was just x squared plus x, then you would have to put plus 0 and your constant term would be 0. Or you could have that middle term missing. If you look at the worksheet, there was like a v squared minus 9 or something. You have to put a 0v in for b. So if the b or c term are missing, you have to put a 0 in. Now you can't have a missing x squared term, right? If that was missing, it wouldn't be a quadratic formula anymore. But you can't have a missing b and a c, and if they're missing, then they're equal to 0 because there's nothing there. The next step we've already done. Determine the discriminant. Okay? So in this particular one, this particular example, we have b, a, and c. Remember, discriminant is b squared minus 4ac. You can use a calculator. I did this by hand. It'd be 25 plus 440, which is 465. And this is why we do the discriminant first, because if you get 0 solutions back, you don't have to write the whole quadratic formula out. You already know that there's not going to be a solution, right? If this is negative, remember there's 3 cases. If it's positive, it has 2 solutions. If the discriminant is equal to 0, it has 1 solution. If the discriminant is negative, there are no solutions. So you might as well go ahead and do it because it's part of the formula, and if you get a negative number, you don't have to finish the problem out. You can just write no solution, which I think we will run into in one of these examples. Next step is to write the formula out if you haven't written it down already. And like I said, if you do step 7, you've already figured out this part of the formula. So you'll be plugging that number in. So in this particular case, we figured out the discriminant was 465, that will be substituted in for all of that. So it'll just be negative b plus or minus 465 over 2a. Square root of 465. My bad. So in this step, we're plugging in the discriminant. We're plugging in our b value. So b is negative 5. And we're plugging in a as well, 11. Okay, so 11 for a and negative 5 for b. Since c is part of the discriminant, you don't have to plug in c anymore. It's already been done with the discriminant. Now the thing is, you're going to have two answers. We already determined that with the discriminant, and that's because of this plus or minus. Okay, so one will be negative 5 plus that over 22. Or sorry, it'll be positive 5. That'll simplify to positive 5. The other one will be 5 minus that over 22. So next step is to simplify like that. So the negative 5 becomes positive 5. And then 2 times 11 on the bottom becomes 22. And we do need to simplify this, meaning we need to find the biggest perfect square that goes into 465. So what do you guys think? Get that list, right? 1, 4, 9, 16, 25. 25 doesn't work. It'd have to be 75. Then you got 36, 49. What's the next one? 8 times 8, 64, 81. Do any of those fit into 465? Let's take a look. That's why I do these examples. The answer is no, apparently, because I would have broken it down. No, there are no perfect squares that go into that. So we leave it as square root of 465. So if the radical can't be broken down, you just leave it that way. So you got two answers. Now, here's the thing, actually. You could just leave it like that. I don't mind if you leave it as plus or minus. Technically, though, there are two solutions. So x would be equal to this, and it would also be equal to this. And yeah, you would get a decimal back here. I don't know what it's going to be, but maybe it's like 7.4 or something. But as far as precision, you keep it in radical form, because once you get a decimal, you end up rounding. All right, any other questions about that one? I think we have 3 examples to go over today. Next example. We have 2x squared minus 3x equals 4x squared minus 9. So the first thing, like the previous example, is to subtract everything over. Again, on your worksheet, you should have all that done. Okay, so subtract 4x squared, add 9. And notice, these two don't combine. It's your x squared terms that will combine. So it'll be 2x squared minus 4x squared. The other two terms don't have anything to combine. But you do have 2 minus 4, which is going to give you negative 2x squared. So you'll get negative 2x squared minus 3x plus 9. So again, here's your A, here's your B, here's your C. Okay, so it's already arranged highest to smallest, nothing missing. There's your A, B, and C. A is negative 2, B is negative 3, C is 9. We do want to figure out how many solutions it has, so we're going to plug it into the discriminant, which is b squared minus 4ac. So negative 3 squared is 9 minus 4. So you got two negatives here. It becomes positive. 4 times 2 is 8 times 9 is 72. 9 plus 72 is 81. So since the discriminant is positive, it has two solutions. Now the reason I did this example is because we have a perfect square here. Okay? So we're going to have to simplify that formula down even more because the square root of 81 is 9. So when you plug it in right here, that will just become plus or minus 9. Whereas the last example was plus or minus square root of 465, which obviously doesn't simplify down to anything. You already got this written down. Just make sure you have the formula written down somewhere on your worksheet. I personally like to write it every single time, just so I know I'm plugging it into the right thing. Because sometimes if you don't write the formula out, then you plug it in wrong. But that's up to you. You can just write it on top of your worksheet. So we've already figured out the discriminant. So 81 is going to go in here, and then we're going to plug in B and A over here. Okay, so it's square root of 81, and then b is negative 3. So again, the formula is negative b. So you got a negative 3, that's going to become positive. And then on the bottom you have 2a, which is 2 times negative 2. Okay, so next step is to simplify. That will be 3, and that will be negative 4. And here's what I was talking about. The square root of 81 is just 9. So in this simplification step, if it's a perfect square, or if it's a square root that can be broken down even further, go ahead and break it down. So we're going to get, we're still going to get two answers back. This time it's important that we write both of them. So one's going to be 3 plus 9 over negative 4. The other one will be 3 minus 9 over negative 4. All right, so let's do that. Let's break it down into plus and minus. So on the left we have 3 plus 9 over negative 4. 3 plus 9 is 12. 12 divided by negative 4 is negative 3. So that is one of our solutions. Remember, the discriminant said we had 2, so we should have 2. On the right, we have 3 minus 9 over negative 4 is negative 6 over negative 4, which reduces to 3/2, which you could write, if you wanted to, as 1.5. Don't have to. You can leave it as a fraction if you want. But that's why we break it down into two different answers, because there are two answers. Negative 3 is much different than 1.5. Example 3, this one's typed up, at least the first part is. We got 3 minus 8x minus 5x squared equals 2x. Just like before, we want to move everything to the one side, usually move everything to the left. So I'm going to subtract 2x from both sides. Okay, so we need to arrange these, obviously. We need to put this term first because it's x squared. And we need to combine the minus 8x minus 2x, give you minus 10x. And then the 3 will go in the end. So I'm going to do that first. I'm going to group the like terms and then combine them to minus 10x and then rearrange them so that this comes first and then that comes second and that comes third. You don't technically have to. You could see that this is A, B, and C. It's just more consistent if you do it that way. So it would be negative 5x squared minus 10x plus 3. So there's your A, there's your B, there's your C. Okay, so there's your A, B, and C. So if you can move that over a little bit. A is negative 5, B is negative 10, C is 3. We are going to determine the discriminant again, so B squared minus 4AC. And some of that stuff's going to be off the screen, so I have to move it over. Whoops. Let's try this again. There we go. Okay, so in this case, your A is negative. I don't know if we've run into that too much. But it's going to become positive because it's minus 4 times 8 times C, so it's plus 60. So you get 160 for your discriminant. Therefore, this also has two solutions. All right, so make sure you have the formula written out. Then you're going to plug in negative. You're going to plug in B, A, and the discriminant, which is 160, will go inside the radical. So it's negative 10 plus or minus square root of 160 over 2 times negative 5. That will become positive 10. That will become negative 10 on the bottom. And I want to bring up a point about that, actually. This came up with one of my calculus students. They were saying, oh, let's just cancel these. You can't do that. And that's because something is being added or subtracted up here. So you can't just pick and choose and say, well, I'll cancel this and it'll become 1. It doesn't work that way. If it was being multiplied, if it was 10 times radical whatever, then you can do that. But with this plus or minus sign, you can't do that. But what we will do is break this radical down. Since it was radical 160, we will break it down into 16 times 10 because 16 is a perfect square. Square root of 16 is 4. Negative 10 become positive 10 on there. So now we have 10 plus or minus 4 radical 10 over negative 10. Now the next step is a little confusing, but basically you have a term here, you have a term here, and you have a term here. So the first term on the top is 10. The second term is 4 radical 10. The third term on the bottom is negative 10. All three of these terms are even, so they all have a 2 in common. So basically what you can do is you can divide each of these by 2. So that one will become 5. This number will become 2. It will not affect this radical, okay? This is like a brick wall. You can't divide anything into this, okay? You just divide the coefficient. And in the bottom, negative 10 over 2 will become negative 5. So you do have to do that. It's kind of like reducing a fraction. It's like a complicated fraction with a radical in it. And there you go. You get 5 plus or minus 2 radical 10 over negative 5. I'm going to write that on another page. You can barely read that. Okay, so that's what happens when you divide everything by positive 2. Sorry. Then you just write it out as two different answers. So one's going to have a plus and one's going to have a minus. Now again, because you could leave it the way we just had it, okay? So you don't have to write it as two separate answers. You could just leave it that way. That's perfectly acceptable. Just note that it's going to give you two answers because it's plus or minus. All right, I want to do one more example, actually. This won't take but 2 minutes. We'll make this example 4. It's only going to have a few steps here. All right, so solve this. X squared plus x plus 1 equals 0. Like I said, it won't take long. First thing I'm going to do, go ahead and fill in what's missing. So that's actually technically 1x squared. Then it's plus 1x plus 1. That way you know your A is 1, your B is 1, your C is 1. So let's find the discriminant. All right, here's where the issue comes in. Discriminant is b squared minus 4ac, right? So we get 1 squared for b minus 4, 1 for a, 1 for c. What does that simplify to? 1 squared minus 4. So we get the discriminant is negative 3. We don't have to do anything else because that tells us that this has no solution. That's your answer to solving this equation. What that really means is no x value works. No x value makes this equation work. It just simply doesn't exist. No matter what number you plug in for x here, you'll never get 0 back.